Before going into the foundation engineering lecture, first of all, I would like to welcome you all to this course. And assalamu alaikum to everyone. So we are going a brand new course in this semester, which is foundation engineering. But we reached to the foundation engineering after studying geotechnical engineering 1 and in geotechnical engineering 2. So I would like a brief, recap of what we studied in geotechnical engineering 1 and geotechnical engineering 2. And I need your help there so that we can make a smooth transition from one course to another course, or the basic understanding of the Geotech 1 and Geotech 2 course, and then we move towards the foundation engineering. So I would like to request a short discussion here that what we learned in geotechnical engineering 1. It doesn't need to be too specific, but what were main things which we discussed and we learned in the geotechnical engineering 1. Anyone who can contribute, that's more welcome, so please kindly remind me and remind us that what we studied in geotechnical engineering 1. Muhammad Anas, Faisal Tahir, Hamza Ahmed Qureshi, Fahad Asif, Mursaleen Khan, Muhammad Idris, Wasif Ali, Hassan Khan. Anyone? What we learned in the geotechnical engineering 1 course?
सर टाइप्स ऑफ सॉइल पढ़ी थी, क्लासिफिकेशन ऑफ सॉइल पढ़ी थी, बेसिक टेस्ट सॉइल्स पे पढ़े थे.
Okay, that's good. So we studied different types of soils. That, for example, we are given with clay, we are given with sand, we are given with gravels, and there are silty sand, gravelly sand, and we can call that as well. And there are different mixtures there, and how we determine the grain size distribution. We can use the sieve analysis. We can also perform the hydrometer analysis if we are given with the fine grained soils. Then we can classify them based upon their liquid limit, plastic limit, shrinkage limits. So we studied shrinkage limits and those limits as well. And then we move towards a little bit about the compaction characteristics. So we understood that how we can find out the maximum dry density and the optimum moisture contents there. And then we studied the seepage, where we studied the coefficient of permeability depending upon the sand and depending upon the clay, that how the uh, coefficient of permeability or the permeability of the soil will affect the geotechnical properties. So basically, we give you the basic understanding that how we can find out the basic geotechnical properties in geotechnical 1. Now then we moved towards the geotechnical engineering 2. So what we studied in geotechnical engineering 2?
सर डायरेक्ट शीयर टेस्ट पढ़े थे सर.
Good.
स्टैंडर्ड पेनिट्रेशन टेस्ट पढ़ा था सर.
Good.
ड्रेन शीयर टेस्ट पढ़ा था सर.
Good. जबरदस्त, सही है. अच्छा, अब now we studied these tests. So why we performed these tests? So we performed a few tests in Geotech 1, and then we performed a few tests in Geotechnical Engineering 2. Why we performed those tests in the Geotechnical Engineering 2 course? What were the objectives in performing these type of tests, which Wasim mentioned, that we performed direct shear test, we performed standard penetration test, we studied about the vane shear test, and we also discussed the triaxial test as well in good detail. But what was the objective in performing these type of tests?
Sir, to find shear strength parameters.
Excellent. So what are those shear strength parameters?
Sir, cohesion और पाई जो internal friction होता है.
Excellent. Okay, so we were performing those tests to find out the shear strength parameters, and we also performed another test which is related to consolidation. What was the name of that test? So if we want to know about the consolidation characteristics of a soil, what type of test we will perform in our geotechnical lab?
Undrained compression test.
Undrained compression test.
Yes, sir.
Odometer test, sir.
Okay, thank you very
Odometer
much.
test wala, sir.
Okay, odometer test. We can perform the different, that is the shearing stage, when we are performing the drained or undrained compression test. So there we are mainly focusing on the shear behavior or the shear strength of the soil to find out the shear strength parameters, cohesion and friction angle. Now, when we want to do the settlement analysis, or if we want to find out the consolidation behavior, so geotechnical engineers will prefer to perform the odometer test so that they can estimate the amount of settlement or deformations which are occurring due to the applied loads. And if you remember, we put different types of loads on top of the soil, and then we see the change in the height of that specimen in Geotech 2 lab as well. So if you understand that in the phase 1, it's basic properties or basic geotechnical characterization properties which we are interested in, and a student is exposed to see those apparatuses and to get a hands-on experience on how we can perform those basic geotechnical characterization. Then we move towards a bit advanced than the Geotech 1 properties. For example, you get a chance to perform a bit more advanced geotechnical tests, which Wasim mentioned in detail, that different types of tests are performed in geotechnical engineering. Now, once you get that idea that you have the basic information and you have the shear strength parameters information, now how we can use these parameters in building in designing the buildings or different geotechnical structures, for example, embankments, dams there. So this course gives you the basic understanding about how these properties will be used to find out the bearing capacity of the soil, to find out the ultimate bearing capacity of the soil, and also to perform the settlement analysis. Now, how you can use the data from the for example, direct shear test or triaxial test, how you can use those parameters in practically in the designing of the buildings and foundations. Okay, now that is one thing which you will get from for the bearing capacity estimation. The another thing is that when you perform the settlement analysis, we will perform the odometer test. So you already performed and you got the necessary information about the odometer test in Geotech 2. Now we are going to use how we can use that information to see how we can perform the settlement analysis. So that was just a brief short discussion just to give you an idea that what we are going to do in this foundation engineering course. So course aims and CLOs are mentioned in the course outlines. So we are having 3 course CLOs, CLO 1, 2, and 3. And teaching and learning activities, these are the activities. We will take few quizzes, classroom discussions, in-class activities as well. So in class, we will perform a few calculations during the class to solve the problems. Homework assignments, group assignments will be assigned, presentation by students, and reports if needed. Self-study is required. Definitely, if you want to learn anything, you need to study by yourself as well. Any other suitable mean which are covered, which are not covered here, we'll take the midterm examination, final term examination. There is a complex engineering problem in this course as well. So we will give you a design problem that can be solved a little bit, in complex way. In the complex usually means that you need to gather the data from the internet, or the data will be given or shared with the students. So you need to design a shallow foundation or a deep foundation based upon the data provided to you people, and that's why it is a bit different than the normal assignments. It will be a bit complex, or we can call that a bit advanced than the normal assignments and quizzes which you get. The first week we will focus on the introduction of the course, which will be done today, hopefully, and definition, purpose, and different types of the foundations, general requirements of the foundations, steps needed in foundation design, selection of the foundation type, loads on the foundations will be discussed today. Now, there are different types of bearing capacities that will be discussed in the second week, the soil response to the loaded footing, methods of obtaining the bearing capacity, collapse load using the limit equilibrium method, and then we will move towards the Terzaghi bearing capacity theory. We will solve examples on the Terzaghi bearing capacity theory. Obviously, there will be the effect of the water table as well, and we will solve few problems on it. Then we will discuss another theory, which is Meyerhoff's theory of bearing capacity, and we will also discuss the effect of load eccentricity on the bearing capacity, inclined loads, and we will solve the examples on this theory as well. Total and the effective stress analysis, which we discussed in the geotechnical engineering 2, now how that is practically affected in this. We got some message here. Is our voice clear? I think so. From my side, there is no issue so far. But if there is, Junaid, please kindly check your connectivity issue. If restart your router there, so maybe it will solve the voice issue there. Okay. Actually, here it's also not good, so I'm using my cell phone internet. I hope I won't get any call on my cell phone because it will disconnect the class. But anyways, That's how we are dealing with the pandemic now. We need to be used to the pandemic. So we were here at the total and effective stress bearing capacity analysis. So we will discuss allowable stress design, limit state design, and we will solve a few examples in it. Then we will move towards the introduction part of the settlement and different types of settlement, immediate settlements and consolidation settlements, and the secondary settlements, and we will solve and we'll discuss the theory of elasticity, and we will solve few examples on it. Then elastic modulus, they are very important in determining the elasticity or the settlement of the soil. So we will discuss few methods that how we can find out the modulus of elasticity from the field tests and from the lab test. Allowable bearing capacity from the field test using the SPT, and how the design and value can be taken. We will solve examples on this as well, and then we will discuss the plate load test, that how we can find out the bearing capacity and settlement from the plate load test. We will solve examples related to the SPT and the plate load, and then we will have our midterm in the 9th week of this semester. Primary consolidation settlement examples, time rate of settlement examples, types of retaining walls and the mode of failure, stability of the rigid retaining walls and the examples, and different drainage methods, types of pile foundations will be discussed, which are related to the deep foundations, which is also a very important chapter in our course there. So we will be focusing on the shallow foundations. So basically here we are focusing on the shallow foundations, and we will tell you that what is a shallow foundation, what is a deep foundation. But we will start with the introduction lecture. Okay, so the different types of piles will be discussed in the deep foundations lectures, types of hammers, selection of hammers, static capacity, negative skin friction, pile load test, efficiency of the pile groups when the pile is constructed singly, and if it is placed in the groups, how it will affect the bearing capacity of that foundation or the soil. Rest of the things, different vibro compaction techniques and dynamic compaction techniques. I think we touched a little bit about the compaction techniques in Geotech 1, Geotech 1 course there, and then we will end up with the final term examination. Grading will be done as per the department policy. This is the syllabus and recommendation. Recommended books are also given here. So you can go for the R.F. Craig book, or you can go for the Soil Mechanics and Foundation book by Budu. And you can also read the Foundation Analysis and Design book by Bowles. Online resources are also available, so you can search the internet resources. You can download any book which you will find interesting for your reading. So that was all about the course content and the weekly lectures. Now we will move towards the introduction part. Now let us consider a frame. So this is the frame here. So this is the frame, and a column is constructed here, and it is applying a load of 40 tons initially. So I would call it figure 1.1a. This is the frame here. The middle column is 1 feet into 1 feet cross section, and it carries a load of 40 tons, which has to be transmitted to the soil safely. So what we are going to do, the ultimate pressure we need to estimate, and we need to estimate the allowable pressure. What are the ultimate pressure? What are the allowable pressure? Now we will find out. The ultimate pressure that will cause shear failure of the soil is 10 ton per square feet. Okay, if a factor of safety equal to 4 against the shear failure is assumed. So we will assume the factor of safety of 4, and that assumption is discussed at the end of this slide or this page, that why we assume different types of factor of safety. But for the time being, just to let you know that this is just an introduction to give you an idea that what we are going to study in this course. So it's just like a basis, and then we will go in detail of each and every term and each and every concept which we are discussing today. So the allowable pressure intensity on the soil will be, so you can divide that 10 ton per square feet divided by the factor of safety which we are taking, and we will come up with the 2.5 ton per square feet. So this will be the allowable pressure intensity in order to avoid the shear failure. Just to let you know, guys, here that we satisfy two design criteria. The first one is the shear failure criteria, and the another one is the settlement criteria. For the shear failure criteria, the allowable pressure intensity on that soil will be 2.5 ton per square feet. Now, however, the allowable pressure intensity to limit the foundation settlement to 1 inch or 25 millimeter, that will be 1.8 ton per square feet. So in order to satisfy the shear failure criteria, 2.5 ton per square feet is required. And in order to satisfy the settlement criteria of that foundation, 1.8 ton per square feet is required. Now, we will do the necessary calculation based upon the current dimension here. This one. So 1 into 1 feet is the dimension of the current foundation, for example. Now, in this case, the area is 1 square feet, and the pressure on the soil would be 40 tons per square feet, which is quite huge, to sustain for that soil. Now, this pressure exceeds both limits of the shear failure. Now, we were given with the criteria for the shear failure that this soil can only take 2.5 ton per square feet. And for the settlement, for 25 millimeter settlement to occur, the criteria says that the soil can only take 1.5 ton per square feet. And now here we are getting 40 ton per square feet. It's very, very huge pressure. Now we need to think about another alternative, that how we can transfer that 40 tons to the soil. One option which we will pick, we will increase the area of the footing. For example, we are placing a footing here beneath that column. And for the time being, and for just an assumption, we are taking 5 into 5 feet of that foundation. So the total area will be 25 feet, and now the pressure intensity is reduced to 1.6 ton per square feet. Now you can clearly see that we have reduced the pressure intensity from 40 ton per square feet to 1.6 ton per square feet by increasing the foundation width and the length of the foundation. This pressure is less the allowable pressure to prevent the shear failure, and also less the pressure intensity. So it's just reminding us that it is less than both the criteria which we were given with. Now the factor of safety against the shear failure is now increased to 10 divided by 1.6 is equal to 6.25. So the factor of safety is quite greater, and the foundation settlement is within the 1 inch limit. Now we can clearly see here that the governing criteria, and what is the governing criteria? So if you see here and if you compare these two, so you can see that 2.5 ton per square feet was required to satisfy the shear failure criteria. But in case of the settlement, so we were given with 1.8 ton per square feet. So it's the least value which will govern. So if we take right now that the smallest value between these two criterias will govern the design criteria for that foundation. That was just an overview that how we approach towards transferring that load to the soil. Then how to calculate the ultimate pressure intensity, which will cause the shear failure of the soil, will be discussed in chapter number 2, which is related to the shallow foundations. And in chapter number 4, we will discuss about the pile foundations, which are deep foundations, and how to estimate the foundation settlement will be covered in chapter number 3, and for shallow, and for chapter number 4 for the deep foundation. So we need to check those two criterias which we discussed in this simple example here to satisfy the design shear failure criteria and the settlement criteria. Now we took a factor of safety. We applied a factor of safety here. Factor of safety equal to 4 was applied, and I told you that we will discuss here that why we apply the factor of safety. So let's have an open discussion why we apply a factor of safety in designing a foundation. So I will repeat the question, that why we apply a factor of safety in designing a foundation.
सर सेफ्टी को इंक्रीज करने के लिए सर
Okay,
सेफ्टी को इंक्रीज करने के लिए
so should I go for 3 factor of safety? Should I go for 6 factor of safety? Should I go for 10 factor of safety? How we select the number for the factor of safety?
Sir, it can be selected on the basis of natural hazards. If natural hazards are frequently occurring, so we will select more factor of safety.
Much closer. Thank you, Wasim, and thank you, Nadeem. Much closer, but still, more specific informations are needed here to understand that why we apply factor of safety in designing a foundation. So natural hazards are also one of the causes that can lead us to assume a factor of safety in designing the foundations. Good. Hint is that we already discussed in geotechnical engineering too, and it's related to the soils. Another second hint will be performing test in the field and performing test in the lab.
सर मटेरियल प्रॉपर्टीज की बुनियाद पर हम फैक्टर ऑफ सेफ्टी लेते हैं सर
Excellent. Now we are moving towards the answer. So Wasim is saying that we are focusing on the material properties. Now, what are these properties and how these properties are obtained? Those are the critical questions that a geotechnical engineer must ask himself or herself. So, how we obtained these geotechnical properties?
by different types of tests like direct shear test sir odometer
Exactly.
test
Excellent. Now we have the limitations in the lab that, you know, if you perform the test in the lab using direct shear test, if you perform the test in the field, the results will be different. So based upon, and even we have the sample disturbance issue as well. If we are, let's suppose, performing an SPT test in Ahmedabad, and we want to bring those samples from that site to Peshawar, UT Peshawar Geotechnical Lab. So how the samples were collected, who collected those samples, and then how the samples were brought to the geotechnical engineering lab here, and then who performed the test and what type of test was performed here, and then how we calculated the shear strength parameters. So you can guess or you can imagine that what I'm trying to say, that lots of uncertainties are involved here to get to the cohesion and friction angle value. It's not just a value which you get, but how you got those samples, how you transported those samples, who performed that test, and what type of test was performed in the lab. These all activities are the sub activities in getting the shear strength parameters. These parameters will then lead the geotechnical design, and you can clearly see there are lots of uncertainties. You know, we can perform standard penetration tests, we can perform cone penetration tests. So in order to avoid those uncertainties, usually geotechnical engineers are mostly, you know, the structural engineers will assume a factor of safety. So they can go for a factor of safety based upon those uncertainties, and then that factor of safety and that assumption will lead to the dimensions of the foundations, and which can be costlier because we don't know. But if you know the shear strength parameters with the accuracy level, you know, near to the, you know, 90 to, I would call it 95%, 100% is impossible. But if you reach to 80 to 90%, then it can significantly reduce your dimensions, and it can significantly reduce the cost of the foundations and overall project. Okay, now what they have written, note the higher factor of safety generally used in foundation engineering because there is natural variation in soil properties. Yes, natural hazards are there, earthquakes are there, but the intrinsic properties of the soil are different. Sampling and testing techniques are not perfect. Theories to find bearing capacity have limitations. Excellent point. Now we will discuss Terzaghi's bearing capacity theory. We will also discuss the Meyerhoff's bearing capacity theory, where those shear strength parameters will be used, and those theories are coming up with the assumptions which are also not, you know, practically feasible there, but in order to get an estimate of the bearing capacity, we come up with the bearing capacity, ultimate bearing capacity, and the allowable bearing capacity. Foundation failure are difficult and expensive to repair. Yes, we need to avoid. Therefore, the higher factor of safety is generally practiced in the design of the foundation. So that was just an introduction and an overview that what we are going to experience in this course. This is the foundation which we discussed, that if we are just constructing a frame structure on top of this soil to transfer this load to the soil, now the better option is to give a foundation here, and then you can safely transfer that load to the soil. But it will be dependent upon the type of the soil and the number of stories or the load which is applied onto that soil. Now, who is a foundation engineer, and how we can train and prepare a foundation engineer that will lead to the design of different types of foundations? First of all, you need training and experience in scientific principles and engineering judgment, and that's what we are doing as a teacher. We are doing we are sharing the training and the experience and the scientific principles to the students. For example, we discussed about the basic geotechnical properties, and then we discussed about the advanced geotechnical properties or the shear strength properties, and we also discussed about the principles involved, that how we can find out the settlement, and how we can find out the deformations, and how we can find out the shear strength of the soils using different types of tests, and what type of test is feasible in which condition, which was discussed in Geotech 2 lectures and the presentations in good detail. So that's all related to your education, your training, and your experience. Now, the formal scientific principles can be understood using the educational courses which we are teaching here at the university. You also teach the structural analysis design in the RCD courses, and the steel structures, which will be taught, I guess, in the final semester in the 8th one. And continued self-study, you can take the short courses, you can discuss with your friends, and you can also get a chance to go into the in the industry or in the field. You can also even go in the neighborhood that people are constructing foundations. I have requested Irshad Saab and the Chairman Saab to sign an MOU with the NESPAC, so that we can send our students to the internships to NESPAC, that what kind of projects, for example, if they are doing practical projects there, so MOU is also under process there. So then we can send a few students, 2 or 3, depending upon their availability, and depending upon their interest, that if they want to continue research in the field of geotechnical engineer, so they can work on the slope stability issues the NESPAC is handling there. And we are trying our best to get a paid internship, but let's see how it goes. But we are focusing on improving the exposure of the students to real field geotechnical engineering projects in the near future, inshallah. Now, different types of foundations. We are basically given with the shallow foundations and the deep foundations. Now, what are the shallow foundations? When we are having depth to width ratio of less than or equal to 1, or even 1 to 3, that will be called as the shallow foundations. There are different types of shallow foundations. For example, spread single isolated footing, so which you usually see at homes, that a footing carrying a single column is called a spread footing. So these are the examples. For example, this is also a spread footing. This one you will also see, this one, and here and here. Now, why we provide those steps and the slopes there? Just to avoid the concrete. If you want to construct, for example, a stepped or slope footings, so usually to reduce the quantity of concrete, we apply those, we construct these kind of step footings. Strip and wall footings, if you see below the wall, so there is a little bit wider area compared to the wall, then that is known as the strip or the wall footing. And yes, here is the combined footing. Now, why we go for the combined footing? So sometimes it's difficult to place a column at a particular location. There might be different reasons. For example, if you are controlling the eccentricity or the movements which are applied onto one column, and it can also affect the non-uniformity in the soil pressures beneath the foundations. Now, in those cases, we provide the combined footings there as well. So you can go for a rectangular option. So You can also go for the trapezoid option, depending upon the loads which are applied onto that area. So you can combine the unequal column loads. So it's better to combine 3 columns here so that equal pressure will be applied onto that soil. Sometimes, it's better to go for the combined footing if you are near the property line. So it's better to go for the combined footing option. There are different types of combined footing options. For example, 2 loads are applied here, and if they are eccentric, so it can cause the non-uniform distribution beneath the foundation here. So it's better to go for a rectangular foundation. Sometimes loads are applied more onto the column which are close to the property line, or if you're having another house here or any other structure here. So it's better to thicken this area so that the load is distributed equally onto this area and the moments are also uniformly distributed beneath that area. Sometimes we also provide a strap instead of the, if you see here, the concrete is utilized too much, and even in the trapezoid option here as well. So sometimes if the loads and the moments are not too much, so in order to distribute that load uniformly to the soil, so you can also have a strap here in between those 2 columns there and 2 foundations. Then it can equally distribute the foundation, the load onto that soil as well. So that is known as straight foundation. Now you can see here that 2 columns are applying load here onto the foundation having length L. It's obviously seen as the combined footing. So you can take the summation of movement at column number 1 equal to 0. Then you can find out the centroidal distance, and you can also find out the half length of that foundation. Just to let you know that these types of foundations are really difficult. Like if you are constructing, for example, the strap foundation and even the trapezoidal foundation, usually the constructors, they try to avoid these types of foundations because extra formwork is needed. They usually prefer this kind of foundation because the formwork is easy to purchase and you can construct them easily. And even for the single footing as well, the spread footing as well, these are easy to construct. So constructors usually go for these options. Just about the strap footing here. Here is an example, just to let you know that these types of conventional methods are not discussed in this course, but that's how a structural engineer approach and look into the designing of the foundation. Now, our main focus in this course mainly is on the ultimate bearing capacity and the allowable bearing capacity of the soil. But this is a method just to give you an idea and overview that how a structural engineer perform the foundation design and how he considers the dead load and live load and the moments created due to the live load and dead load. So he take into consideration the compressive strength of the concrete and the yield strength of the steel there. And if this is the Q allowable, this Q allowable is provided by the geotechnical engineer, which will be our focus in this course, that how we will reach to the allowable and the ultimate bearing capacity. A method is discussed here to find out the centroidal distance. So you can simply take the moments onto one column and equal to 0, and then you can come up with the X bar and the length of that footing is also calculated, and then you can do the P ultimate is equal to B into L into Q ultimate, so you can come up with the width of the foundations. Lots of problems will be solved, that how we reach to the width of the foundation and how we reach to the length of the foundation, what type of soil parameters will be discussed. But this is just a general overview that how a structural engineer looks into the problems and how he uses those values of the ultimate and allowable bearing capacity. Another example is also given, which is just for the introduction purposes, that how the dead load and the live loads are taken into consideration. Now, if the soil is weak and if the spread footings or the single isolated footings are taking more than 50% of the area, for example, like this here, you can see that if this area is 50% or more of that 50% area is covered by the isolated footing, then it's better to go for the uh, mat foundation. So, some people call that as a raft foundation as well. Now, there are few advantages because the soil conditions are imposed in such a way that the bearing capacity which the structural engineer is giving you the loads. So how it goes in the design process, that the structural engineer will say that I want to build a, for example, earthquake engineering center at the Department of Civil Engineering. Now, we are given with the earthquake engineering center, which is the older one, and we are given with the earthquake engineering center, which is for example, the new one, and the number of stories are different and the load conditions are different. So we are given with a soil beneath the foundations there, and most probably the soil conditions won't change at all. So you need to see, you need to perform the basic geotechnical test, and then we need to perform the advanced or the shear strength parameters test as well. So, for example, we come up with a loading conditions that the loads are unable to take the taken by the soil there, and it's a very weak soil, so we can go for a mat foundation. Usually if you see in big malls which are constructing right now on the ring road or even on the university road, they are going for the raft or mat foundations just to avoid that there will be a significant settlement problems. One option maybe they're going because we are not more focusing on obtaining the real geotechnical properties of the soil, so that's why they go for the mat foundations, which are very, very costly, and we will discuss right now that the cost of the mat foundation is quite huge. And the reason behind that increase in the cost is that we provide positive and negative reinforcement steels there, and it will add up to the cost of the project. Sometimes people avoid the negative reinforcement issue using the fiber spacer boards to separate the footings board after the construction there. So there are different types of mat foundations, as also given flat plate and flat thickened under columns, just to give them a good grip into the soil. There are different kind of basement walls are also provided in mat foundations. Flat with the pedestals are also provided here. So these are different options which geotechnical engineer can go for if we are having different soil conditions. So these are the spacer boards which I was talking about. So instead of going for the whole area, so sometimes we can go for a spacer board in between there so that we can avoid the negative reinforcement issue there. But that option can only be selected if we can trust the soil, that this soil is not significantly weak and it is having a reasonable shear strength, and that reasonable shear strength will be discussed in chapter number 2. Now, if a shallow foundation is not working at a site, now what are the other options? So we are given with the deep foundations option as well, in which the depth into width ratio or length into breadth ratio is greater than 4 or equal to 4. So that's why we call that depth to width ratio. 1 to 3 is for the shallow foundations, and greater than or equal to 4 is for the deep foundations. So that will be discussed in the piles foundation chapter, that how the piles are designed, how the piles dimensions are derived based upon the different soil conditions. So here we are going to discuss all of these deep foundations options. Different types of deep foundations will also be discussed in chapter number 4. Now, there are different requirements for a foundation system. What kind of requirements we usually focus mainly on? And safety requirement, we will not compromise on the safety of a structure there. So that is also one of the reasons that we apply the factor of safety, that just in case that we were unable to collect good samples, just in case that we were unable to perform at the right test, let's apply the factor of safety. For example, if we estimate that 100 students will come to the new earthquake engineering center building here, there are classrooms on the top of the earthquake engineering center, and for some reasons 200 students come for a seminar, or for example for a conference here, or even for a demonstration that how the shaking table test is performed here. So sometimes a huge amount of people, or a lot of people will come here and they will watch the shaking table test. So we need to consider all these live loads, I would call that, and that live load and dead loads are also considered in the design structure, which can be seen, for example, here, and maybe you will learn those 1.4, those factors there, that for example the dead load is this much, so let's have a factor of safety or a factor increased by 1.4 that we don't know. So this is the uncertainty which is involved in designing the structure for and determining the load, and that's how the structural engineer will give you the details about the dead load and the live load which is applied on top of the soil. Settlement requirements, obviously we should avoid the total and differential settlement, and which can also lead to the structural failure. So these are the safety requirements. There should be a depth requirement as well, which will allow us that we already know in Geotech 2 that the volume of the soil will change when we have a moisture present in there, or for example if the soil is freezed, and then if it is thawed, means if you are dealing in the northern areas of the Pakistan, or if we are dealing in the southern areas of the Pakistan, Balochistan here, then the soil properties will change and there will be significant difference in the volume of the soil, and that volumetric change in the soil can lead to the total, or most probably the differential settlement in those foundations. So we should avoid the moisture fluctuation zone, freezing and thawing zone. We should also provide a certain depth that the wind or the erosion won't occur due to the water. Other unsuitable soil layer, for example, if you are experiencing organic soils there, you might have seen in houses, in villages, we dump lots of stuff in a particular area, and later on we want to construct and build a structure there. So those soils, those peat soils, organic soils, are deadly for the differential settlement, and that can significantly lead to the foundations. Any question, please, Hamza? Okay, great. Okay, let me finish the lecture, then we can go for the question and answer. And now, it's expensive play. It's an expensive A. It's ANSIV, and expensive means that there are different types of minerals present in clay soils that when you add water into that soil, they will swell, and if it dries, then it will contract, which can also lead to significant differential settlements. You can also avoid the movement or distortion by the plant or tree root. You might have seen lots of roots, growing up beneath the bigger. They can also crack or different in conditions. Spacing in these conditions, we will
सर आई थिंक आपके साथ प्रॉब्लम है सर वॉइस की एक्सक्यूज मी सर
सर डिस्कनेक्ट हो गए हैं। अगर किसी के पास नंबर वगैरह हो तो इन्फॉर्म कर ले।
Assalamu alaikum.
वालेकुम सलाम सर।
Okay, where I left you guys? Wasim, please
डीप
kindly.
फाउंडेशन स्टार्ट की सर।
यहाँ पे मैं तो लेक्चर ऑलमोस्ट खत्म कर चुका हूँ।
नहीं सर, डीप फाउंडेशन बस शुरुआत ही थी, फैक्टर ऑफ सेफ्टी से नीचे थोड़े गए थे सर।
Depth requirements. Acha, depth requirements. So first of all, the safety requirements should be
शेयर करें
fulfilled.
सर, स्क्रीन शेयर
Okay.
करें सर।
Okay, thank you. आपकी क्लास का सीआर कौन है?
एहतशाम अरशद।
अच्छा एहतशाम, काइंडली ऐसा कोई इशू हो तो फिर डायरेक्टली मुझे आप कॉल कर सकते हैं, ठीक है, या मुझे टेक्स्ट कर लें पहले कि मैं कोशिश करता हूं कि मैं कमेंट्स को और उसको ना देखूं ड्यूरिंग द लेक्चर, ठीक है, कॉल को भी मैं पिक ना करूं। तो काइंडली अगर ऐसा इशू हो तो ये तो जेन्युइन इशू है, तो इसमें आप मुझे कॉल कर सकते हैं ड्यूरिंग द क्लास के सर ये जो क्लास है ये हमारे पास कनेक्टिविटी इशू की वजह से आई डोंट नो कि क्यों यहाँ पे मेरी तरफ से स्टॉप हुआ है, लेकिन कनेक्टिविटी इश्यूज हर जगह पे आ सकते हैं। तो थैंक यू वेरी मच। पता नहीं लास्ट में मैंने आपसे क्वेश्चन किया कि प्लीज कंफर्म कि आपके पास स्क्रीन और वॉइस क्लियर है कि नहीं है, तो वहां पे मुझे पता चला कि मुझे प्रॉम्प्ट किया गया कि आप दोबारा क्लास को ज्वाइन करें। Anyways, so we will start with the safety requirement. There are different depth requirements, and the depth requirements are based upon the seasonal variation. Or, for example, there is a snow in the northern areas, and hot weather is present in the Balochistan, so that can also affect the depth of the foundation. Moisture fluctuation can cause effect on the depth of the foundation. We should provide the foundation which will not erode due to the wind or due to the water here as well. Unsuitable layers such as peat, expensive. So I made a correction there that you can write that as expansive clay instead of expensive clay. So it's a P and A instead of PE. Now these clays should be avoided because you will see significant settlement in these kind of soils. Therefore it's better to avoid these type of soils and to provide a proper depth in to that foundation, and that will be also discussed in our bearing capacity lecture and the shallow foundations lecture. Now, prevent footing movement or distortion by plant or tree root. You might have seen locally as well that lots of plants and roots they grow, and when they grow they can crack the foundations, so we should also avoid based upon the depth of the foundation. Spacing requirement, we studied about the pressure bulbs and the pressure intensity and the pressure distress which can cause one foundation on the another foundation. So proper spacing should also be provided. Now for the steps for designing a foundation, we need to locate the site and the position of the load. So a rough estimate of the foundation load is needed here. Then we will physically inspect the site for any geological or other evidence that may indicate a potential design problem, and we can note down that what can be a potential problem. For example, it can be it could be the higher groundwater table. It can be a clay soil, expensive soil, or for example, we can say that excavation is done beside the foundation. That can also be a design problem there. So then we will establish the field exploration program, and in the field exploration program you can also perform the laboratory testing program. Now, for example, if you are constructing a house or if you are constructing a Centaurus mall, then the geotechnical testing program will significantly different, and you need to perform different types of advanced tests in case of, and more carefully those tests which are needed as geotechnical investigation. Soil design parameters are obtained in the fourth part, and which can be integrated or related to the scientific principles, engineering judgment. Now, in simple or complex computer analysis may be involved. Now, in computer analysis, Plaxis software is powerful in performing the stability and settlement analysis. There are also other softwares, for example, GeoSlope. They can perform. It can perform, the slope stability analysis quite powerfully. And these are two softwares which undergrad students, after graduating from the university, use in Canada, in North America, and other parts of the country as well. Now, you will come up with the design, the foundation using the soil parameters, and it should be cost effective and timely. It should be done timely and within the duration which it needs to be completed. For the foundation selection process, there are different factors which are involved. For example, structural loads, design loads, environmental effects, and the subsurface condition, performance requirement, construction methods, and the economics, which I discussed. That is very, very important as a geotechnical engineer, that even as a design engineer, that it should be completed within the duration which it is allotted, and it should be cost effective. Now, there are, you can read these one, and I will go to this chart here. That first you will obtain the site information. Please confirm that you can hear my voice.
Yes, sir.
Okay. The screen is visible. Okay, that you obtain the site information. Okay, so think like a geotechnical engineer. Now, this is showing you that how you should approach the designing of a foundation. You need the site information, surface topography, hydrology, and the climate of that area. For example, we will take that as Mardan district. Now, you also need to know about the subsurface soil area or the rock strata. Soil rock properties are needed. Groundwater table informations are also needed. Obtain the structure data. What type of structure is it? What kind of performance criteria it should satisfy? How many loads are applied? Now, then we will move towards the evaluation step. In evaluation step, now we will go for the shallow foundation option first, and then for the deep foundation option. And then if deep foundation option is also not working, then we will go for the ground modification for the shallow foundation. So these are the options which we are gonna choose. Now, once we select the foundation, then we go for the predicting the behavior. Now, what kind of behavior we are interested in? We are interested to know the settlement of that foundation, the bearing capacity of the foundation, lateral stability, and the other environmental factors which Nadeem mentioned. That, for example, if it's a seismically active region, then we need to consider the earthquake effects as well. Now, we will determine the feasibility. We will compare the predicted versus the required performance criteria and potential construction problems and cost estimation. If it's feasible, it's okay. If it's not feasible, then we will go for the another foundation type. For example, if you are going for the shallow foundation, if you are going for the deep foundations. And if it is recommended, for example, the shallow foundation is recommended, then you will go for the foundation type, and you will write about the design data, and you will write about the construction procedures. And once that recommendation is done and approved, then you will process is completed, and then you will prepare the detailed design plans and specification, and you start the construction process. So that's all which a foundation selection process says. But let me tell you one very important um, aspect of the geotechnical investigation is preparing a geotechnical investigation report. Here, lots of input is required from a geotechnical engineer, and that is given to the structural engineer or structural design engineer, and that is a must almost for every building which you are constructing legally in any part of the country, in any part in North America or in Canada. People give, if you are given with a structure there, so a geotechnical report must be there, which tells you that what kind of soil and foundation is there. But these are the ingredients, are the subtopics which are covered in the geotechnical investigation report. For example, site description should be given, boring logs and subsurface profiles should be given, results of the lab and field test. Now, what kind of lab tests were performed and what kind of field tests were performed there in, for example, construction of a house or a plaza in Mardan. Now, review of the design loads, then you will review the design loads, because based upon those investigation, you will come up with an estimate that what kind of soil is there and what is the bearing capacity of that soil. And then you will talk to the structural engineer that you need to look into the design loads, because my soil is not very good, or the bearing capacity of that soil is very low. Now you need to redesign or see, if you can reduce that load. If a structural design engineer is saying that okay, you need to modify your soil, then you can go for the modification, or you can go for the other foundation options. Analysis of the behavior of each foundation alternative will be discussed. Evaluation of predicted performance in relation to performance requirements. Discussion of potential construction problems, for example, excavation and dewatering is occurring. Discussion of relative cost if you are taking into consideration the shallow and deep foundations, and depending upon the design loads, you can also come up with the discussion on the cost of each and every alternative. Recommendations will be provided, foundation type is decided, foundation design criteria is decided, and the special construction methods are decided here. And then you will start with the construction process and also the monitoring of that structure. Now, what is the role of the geotechnical engineer here? Even if you submit the geotechnical report to the design engineer, or even for a bigger project, for example, as a Centaurus Mall, so you cannot just give a geotechnical report and to structural engineers, and he will put that Q allowable and Q ultimate in his calculation, and then you leave that structure to construct by itself or by them. Basically, it should be in such a way that a geotechnical engineer will do the site investigation once the plaza or the Centaurus Mall is constructing. He has done the analysis using the software, but he should be there so that he can see that how the soil is behaving practically there in the field. So therefore, in bigger projects like CPEC and bigger projects and bigger organizations, they usually keep a geotechnical engineers just to see the progress of that project as well. Now, I'll show you a few videos, very interesting videos that I think you will enjoy. That the world has moved towards really advanced foundation structures. Instead of the conventional foundations which we see here around us, if you are moving towards the offshore geotechnical engineering area, there people, okay, I would recommend to please lower your earphones. So let me explain first. The the Europe and Far East Asia are moving towards constructing the offshore wind turbines. Why they construct offshore wind turbines? They wanna build green and clean energy. Now, in order to get the clean and green energy, uh, they are going towards the offshore environment where nobody's living there, so less noisy and faster and cost effective, and the wind speed is very, very high compared to the onshore environment. So they construct those, they build those wind farms, and in order to do that, they need foundations, and lots of I would call it billions and billions of dollars are spent, annually on constructing only the foundation, and even the understanding or collecting the samples from these offshore environments. So this is one of the videos which I want to share with you, that how the suction bucket installation is done in soil. I hope you can see it, right? So this is a suction bucket, and this is the project which I also worked on when I was doing my master's at South Korea. Please confirm that you can see the
Yes, sir.
screen.
Here.
Okay, thank you. So it's a suction. If it's only one, this is a monopod. But if it has three legs, then it's called tripod. And suction is applied from the top and is soft soil. So the bucket will go into the sandy soil or the clay soil, and that jacket is removed. These are the pumps which were pumping out that water from inside the bucket. These are known as suction bucket. It's NGI, Norwegian Geotechnical Institute. They are spending billions of dollars on these kind of projects. So that was one video, and in the offshore environment, Dong is another company which deals with the offshore structures. You can see here barges there, and how that barge is now installing the foundations in the offshore environment. So this is basically the valve, which controls the suction of the water out of that bucket there. And because of that suction, the bucket is going downwards. Now it's resting on the soil, which can transfer the load. Now you can uninstall that using pressurized water as well, if you want. Our main task was to get the soil data from the offshore environment, and then we need to see the cyclic behavior of the soil. So it was a collaborative project between like 7 universities of South Korea during my master's, and we investigated the dynamic properties of the soil because the waves will come onto that foundation. Now, how that soil will behave during the dynamic load, and even the wind loads also applied, which will change the properties of the soil. So one university was building on the structural side, the another one was working on the numerical investigation of those kind of structures. Another university was working on the electrical aspects of the offshore wind turbine foundation. Our task was to investigate the soil properties of
सर
that soil.
सर ये समंदर था।
Sorry, बोले जी।
सर ये समंदर था। हेलो सर।
Can you hear me now?
Yes sir, I hear you.
Okay, actually it's upturned bucket होता है. It is kind of a cylinder you can call that. उसको उल्टा करते हैं और उससे सक्शन किया जाता है और जो वाटर को सक किया जाता है, तो बेसिकली उस सक्शन की वजह से ये नीचे चलता जाता है और ये नीचे
सर
इसको
मेरा क्वेश्चन ये था सर कि ये समंदर में वाइंड एनर्जी क्यों ले रहे हैं सर, टाइडल एनर्जी क्यों नहीं लेते इससे?
नहीं, क्या मतलब कि बॉयंट एनर्जी क्यों ले रहे हैं और ये टाइडल एनर्जी क्यों नहीं ले रहे हैं?
सर मतलब ये ओपन के साथ लगा रहे सर, इसको मैं उसका नेम भूल गया सर, जो हवा से सर इलेक्ट्रिसिटी लेते हैं सर।
अच्छा, आप वो हाइड्रो पावर की बात कर रहे हैं?
यस सर।
हाइड्रो की देखिए, वो बहुत एडवांस मुल्क हैं। वो एडवांस मुल्क जो है ना, वो सिर्फ नॉइज की वजह से भी जो है ना पोल्यूशन क्रिएट होता है। वो पोल्यूशन बहुत बड़ा इशू होता है। 30%, ये 2013 की मैं स्टेटिस्टिक आपको बता रहा हूँ, 2013 की, जिस टाइम मैं उधर उस पर रिसर्च कर रहा था। 30% जो ब्रिटिश है ना, वो विंड फार्म्स बना रहे थे। कहते हैं कि ये जो ऑन शोर पे विंड फार्म बनाते हैं तो ये बहुत नॉइज क्रिएट करता है। और दूसरी बात ये है कि यहाँ पे हमारे पास विंड की जो एनर्जी है, विंड की जो स्पीड है, वो बहुत ज्यादा होती है। तो यहाँ से बहुत ज्यादा कैपेसिटी में हम इससे इलेक्ट्रिसिटी प्रोड्यूस कर सकते हैं। अपार्ट फ्रॉम दैट, क्योंकि हमारा जो एरिया है उसमें टेरेन का भी जो है ना इशू हो सकता है कि वहां पे उनकी नहीं है, तो हो सकता है कि वो उस तरफ जाए। या मैंने जो आपको बताया कि ये हाइड्रो की बात कर रहे हैं, ये ऑन शोर पे इनके साथ बर्ड्स लगते हैं और इनके साथ होती है, तो जो घर वाले हैं वो फिर कंप्लेन, सो दे दोज विंड फार्म्स। विंड फार्म्स ये होते हैं कि 100, 200, 300 या 500 या 1000 का जो है ना वो विंड टर्बाइंस आप लगाएं, उससे आप जो है ना एक station लगाएं, and then you generate that energy, and that is clean and green energy. So they are practically focusing on that clean energy. Apart from that, you can create lots of noise there in hydropower, and steepness and other parameters are also involved in preparing those kind of electricity projects. Okay, so that's how they construct these national plates. If you're for example, there are onshore wind turbines somewhere in Balochistan, in Karachi. They are present as well. You need to use the gravity-based foundation.
Excuse me, sir.
कौन बोल रहे हैं? Excuse me, बोला है. Anyways, you can. अच्छा, आपको आवाज आ रही है कि नहीं आ रही है?
सर आवाज आ रही है लेकिन वॉइस प्रॉब्लम है सर.
नहीं, अच्छा, वॉइस प्रॉब्लम है. नहीं, ये तो वीडियो में वैसे थोड़ा बहुत इशू है, लेकिन ये मैं आपको इसको मैं आप म्यूट भी कर सकते हैं, कोई मसला नहीं है. ठीक है, हाँ ये है इसमें, आप इसको स्लो कर लें. ठीक है, वो इशू वीडियो में है, ठीक है ना. तो आप उसको काइंडली आप म्यूट कर सकते हैं उसको, या थोड़ा स्लो रखें तो फिर आपको थोड़ा बहुत वो करेगा. ठीक है, इस तरह फिर साइट को बनाते हैं, रीबार्स लगाते हैं. ऑनशोर पे इसको कैसे कंस्ट्रक्ट किया जा सकता है ये इसमें दिखाया जा रहा है. और ये ऑलरेडी पाकिस्तान में कंस्ट्रक्ट हुए हैं, बलूचिस्तान और सिंध में. ग्रिडिंग करते हैं, थोड़ा सा स्लो कर लें. ठीक है, ये थोड़ा सा इसकी जो वीडियो क्वालिटी है इतनी अच्छी नहीं है, तो अगर आप सकते हैं तो अच्छा है. तो ये आपके पास फाइनली जो है ना, वो इसको कहते हैं ग्रेविटी बेस्ड फाउंडेशन. ठीक है, इसको ग्रेविटी बेस्ड फाउंडेशन आप खैर यूट्यूब पे सर्च भी कर सकते हैं. तो उसके लिए अगर आप सेक्शन बकेट फाउंडेशन इन ऑफशोर एनवायरनमेंट वो सर्च करते हैं, या गूगल में आप इसको विंड फार्म फाउंडेशन कंस्ट्रक्शन ग्रेविटी बेस्ड फाउंडेशन, तो ये वीडियो नेट पे भी अवेलेबल है आपके पास. अच्छा, बाकी हमारे पास और जो है ना एडवांस फाउंडेशंस जो है ना अवेलेबल हैं. उस पे आप ये वीडियो बुर्ज अल अरब की फाउंडेशन भी देख सकते हैं, बुर्ज दुबई की भी देख सकते हैं. नेशनल ज्योग्राफी की रियन एंट्रियन वीडियो जो है ना आप जरूर देखें. ये मैंने कनाडा में जो है ना मेरे सुपरवाइजर जो थे उन्होंने मुझे कहा था कि आप अंडर ग्रेड स्टूडेंट्स को दिखाएं, तो इसको फिर मैंने एक्सप्लेन भी किया था उनको, बताया भी था कि इसमें कौन कौन से इश्यूज जो है ना वो आ सकते हैं, और वो आए थे और उसको कैसे रिजॉल्व किया था. तो उस पे थोड़ा स्लो कर लें इसको. अच्छा, ये जो है ना हमारे पास देखें फाउंडेशन पे की डिफरेंट ऑप्शंस दी गई थी. तो एक कंपनी ने उसको कहा कि यहाँ पे अगर हम इसमें पाइल्स लगाते हैं ना, वो अगर उसको एम्बेड करते हैं, तो इसने कहा कि 300 तक इन्होंने पाइल्स एक पियर के नीचे जो है लगाई. ठीक है, अभी आपको आवाज आ रही है? मैंने उसको पास कर दिया. आ रही है?
यस सर, आपकी आवाज आ रही है.
अच्छा, फहद, इज इट क्लियर
Yes,
नाउ?
sir.
ठीक है,
Yes, sir.
चलेंगे चलेंगे। अच्छा, आप इसको प्लीज जो है ना वो नेशनल जियोग्राफिक रीजन एंटीरियन ब्रिज पे जो है ना, अगर आपके पास नेट की कनेक्टिविटी की कोई इशू नहीं है तो ये किस तरीके से फिर लिक्विफेक्शन का इशू आता है, उसको किस तरीके से इन्होंने टैकल किया।
Excuse me, sir.
प्लीज बोल।
सर आपकी आवाज़ में काफ़ी प्रॉब्लम है ना सर, अगर ये नेक्स्ट लेक्चर में एक्सप्लेन कर दे, क्योंकि सर आपकी आवाज़ बार बार कट रही है।
Hello students, can you hear me now?
Yes, sir.
Okay, sorry for the interruption due to the internet connectivity issues here at Earthquake Engineering Center. I usually switch between the mobile internet and the EJROM, but I don't know, sometimes, the signals are very, very weak at Earthquake Engineering Center, so sorry about that. अच्छा, मेन चीज ये है कि इसमें आपने रियन एंड रियन ब्रिज की जो एक वीडियो है वो देखनी है। बुर्ज खलीफा की, बुर्ज अल अरब की जो फाउंडेशंस है वो वीडियो मैंने आपको नहीं दिखाई है, क्योंकि फिर जाने वॉइस का इशू आएगा या कनेक्टिविटी का इशू आएगा। मेन मकसद ये था कि फाउंडेशन इंजीनियरिंग को समझा जाए कि फाउंडेशन इंजीनियरिंग में जो टेक्निकल इंजीनियरिंग के एस्पेक्ट्स हैं उसको कैसे इनकॉर्पोरेट किया जाता है और कौन कौन से एस्पेक्ट्स को स्टडी किया जाता है। लोकली या नेशनली जो टेक्निकल इंजीनियर की इंपॉर्टेंस कितनी ज्यादा है, और इंटरनेशनल प्रोजेक्ट्स में जब आप बुर्ज खलीफा, बुर्ज अल अरब और एनजीआई की ये जो वीडियोस हैं, सक्शन बकेट की वीडियोस हैं, ऑफशोर फाउंडेशन की जो टेक्निकल इंजीनियरिंग की वीडियोस जब आप देखेंगे तो आपका थोड़ा जहन खुलेगा कि ये सिर्फ और सिर्फ एक बिल्डिंग की फाउंडेशन नहीं होती। जो टेक्निकल इंजीनियर का रोल या इन सॉइल की प्रॉपर्टीज को अंडरस्टैंड करना, ये बहुत ही इंपॉर्टेंट होता है। जब आप, अगर खुदा अल्लाह ताला आपको मौका दे कि अगर आप बाहर जाते हैं या बाहर काम करते हैं या बाहर पढ़ने जाते हैं, तो दैट विल हेल्प यू देयर एज वेल। So thank you very much for listening very, very patiently. You can write P in the comment box so that I can write down your attendance as well. Okay. So